This SOS video is about graphing a system of inequalities, and that can help us solve a systems inequality word problem. So recall that a system of inequalities means two or more inequalities that are using the same variables. When we graph a system of inequalities to solve a word problem, we first write a system of linear inequalities that describes the situation, and we remember to define each variable. Then we're going to graph the inequalities. Usually we're going to use the intercepts method instead of the slope-intercept method. This intercepts method is usually the most helpful. Just remember, if y is negative in your inequality, then we're going to reverse the symbol when we're going to shade. Finally, we're usually asked to write at least one solution to the problem. And to do that, you're going to pick an ordered pair in the intersecting region and explain its meaning in context of the situation. Let's see how this works. Allie helps at an animal shelter and is paid $10 an hour. She also works as a cashier at a local store and makes $15 an hour. So the animal shelter, she makes $10 an hour. Cashier at the local store, she makes $15 an hour. She wants to make at least $120 a week, but she's not allowed to work any more than 11 hours, no more than 11 hours. You are to graph the system of inequalities to show all the possible combinations of job hours that will allow her to achieve her goal of earning at least $120 a week. So think of what inequality symbols we're going to use and what two inequalities we're going to write. Pause the video and then start it again when you have an idea. So the first thing is to think about what our unknowns are. We do know how much she's paid per hour at the animal shelter and how much she's paid per hour as a cashier. But what we don't know is how many hours she can work at each of them. So I'm going to say X equals the number of hours worked at the animal shelter. And we're going to let Y equal the number of hours worked as a cashier. And I'm going to label my axes with X and Y. And I'll write the label underneath here. X is the number of hours at the animal shelter. And our Y is the number of hours as a cashier. Okay, we need to write our two inequalities. So one of the inequalities is usually about the quantity, how many of this we have. And the other one is usually about the value, how much money we're going to make, or what's the value of what I have. So when we look at the quantity, we know that no more than 11 hours means I can work up to 11 hours. I can include 11 hours, but I can't go past that. So no more than 11 hours is less than or equal to 11. And the hours she works at the animal shelter is X, and we're going to combine that with the number of hours she works as a cashier, Y. So that's our first inequality. The number of hours worked at the animal shelter plus the number of hours worked as a cashier can't be more than 11. Now let's talk about how she makes her money. So working at the animal shelter, she makes $10 an hour. So 10 is how much she makes for 1 hour at the animal shelter, and X is the number of hours she works there. We're going to add it to the amount of money she makes as a cashier. 1 hour of cashiering is $15, times how many hours she worked is Y. We know that she wants to make at least $120. So she's happy with $120 or more. So at least $120 means greater than or equal to. Okay, so here are our two inequalities. The easy way to graph this is using the intercepts method. So recall that when we are looking for the x-intercept, we're looking for the x value when y is 0. And when we're looking for the y-intercept, we're looking for the y value when x is 0. So to draw the boundary line, we're going to pretend that this is an equals. So we're looking for x when y is 0, and that would equal 11, which means x is 11, and 11, 0 would be one of the points of the boundary line. Well, the y-intercept is our y value when x is 0. So we're going to write when x is 0, what would y be? It's less than or equal to 11, so we're just going to say 11 for the boundary line. And that means y equals 11. So the other point of our boundary line is 0, 11. Because this has an equal sign underneath, we know it's going to be solid. And because y is positive, if I was going to isolate y, I would not have to reverse the symbol. I would only do that when y is negative. So that means our symbol, our inequality symbol remains the same. We're going to graph less than or equal to. We're not going to start setting up our intervals just yet because we need to know what our boundary line points are going to be for this one. And again, we're looking at our x-intercept. So we're looking for x when y is 0, and we'll look for our y-intercept, okay, and that's when x is 0. Okay, so if we're looking for x here, and y is 0, 15 times 0 is 0, so what is it when 10x is greater than or equal to 120? For our boundary line, we're going to pretend it's 10x equals 120, so x would be 12. And one point of the boundary line would be 12, 0. Well, what happens for the y-intercept? Well, x would be 0, which means we're left with 15y equals 120. I divide both sides by 15, and I get y equals 8. So the other endpoint of the boundary line would be 0, 8. This is going to be a solid line because this line is underneath the inequality symbol. And I look to see what the sign is for y, and it's positive. So if I was going to isolate y, I would never reverse the symbol. So this symbol remains the same. It's going to be greater than or equal to. Now we're ready to graph. So I take a look at my x values, and I said, okay, the most I'm going to go on my graph is 12. And do I have 12 boxes here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I do. So I can count by ones. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. To graph on the y-axis, I'm going to take a look at the points I have here. And the highest y value is 11. And I definitely have 11 boxes here. I'm also going to count by 1. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We just made it. Okay, so let's graph this first boundary line. That would be at 11, 0, which is this point, and 0, 11, which is here. You're going to take your straight edge, and we're going to connect those two endpoints. Remember, this was our solid line, so I'll graph this. And we are going to graph less than or equal to. Remember your hiker's here on the line, less than or equal to is below. If you're not sure, pick a point here and test it in your inequality to see if it makes it true. If I pick this point, testing point 2, 2, is it true that 2 plus 2 is less than or equal to 11? Well, 4 is less than or equal to 11, so this point works, which means everything in here will be a solution. So I'm going to shade below. And you only need about 5 or 6 of these lines to show this intersecting region. I'm also going to write my inequality somewhere there. Okay, remember, it's a system of inequalities, so that means I'm going to need to graph this one as well. So I look at my boundary points. 12, 0 is over here, and 0, 8 is over here. Since this was greater than or equal to, we connect it with a solid line. And we are shading above, greater than or equal to. So shading above means going in this direction. And you want to cross this entire plane. And I'm going to write my inequality somewhere in the shaded region. Okay, there's not a lot of space where they intersect, but they do intersect here. So I'm going to write an S in this space to show this is my solution set. Any point I pick here should work for both of these. So that is how you graph the system of inequalities in a word problem. Pause, make sure you understand that, and now we're going to analyze it. Okay, you're asked to determine and state one combination of hours that will allow Allie to earn at least $120 a week while working no more than 11 hours, which is what we graphed here. And you're going to explain your answer in context of the situation. So I can say, okay, I'll pick any point here. What if I pick 3, 7? That point is definitely in the shaded region. Just to make certain, I'm going to show you algebraically that this does work. One of our inequalities was x plus y is less than or equal to 11. This is my x value, my y value. 3 plus 7 is less than or equal to 11. 10 is less than or equal to 11. So I know that point works for that inequality. Well, let's take a look at this other inequality. 10x plus 15y is greater than or equal to 120. 10 times 3 plus 15 times 7 greater than or equal to 120. So is it true that 30 plus, let's see, 5, 3, 105 is greater than or equal to 120? And 135 is greater than or equal to 120. So that point also works for this. So we know that that is an ordered pair that is a solution. Well, what does that mean in context of the situation? So sometimes it's helpful to write down the label for each of these values. This is my x, this is my y. So x is the hours at the animal shelter, and our y value is the number of hours as a cashier. So when Allie works 3 hours at the animal shelter, and 7 hours as a cashier, she will work no more than 11 hours and make at least $120 for the week. Okay? You need to make sure you explain that the 3 represents the number of hours at the animal shelter and the 7 represents the number of hours as a cashier. And that is how graphing a system of inequalities can help us find an answer to a word problem. This is another SOS video.